Section 9.1, 2 Proportions. Key concept. In this section, we present methods for 1. Testing a claim about 2 population proportions, and 2. Constructing a confidence interval estimate of the difference between 2 population proportions. The methods of this chapter can also be used with probabilities or the decimal equivalents of percentages. Inferences about 2 proportions. The objective. Number 1, hypothesis test. Conduct a hypothesis test of a claim about 2 population proportions. Number 2, confidence interval. Construct a confidence interval estimate of the difference between 2 population proportions. So here's the notation for 2 proportions. Okay, so we have 2 populations for population 1 and for population 2. For population 1, we're going to call that P subscript 1, which is the population proportion 1. For population proportion 2, we're going to call that P subscript 2. The size of the first sample is N subscript 1. The size of the second sample will be N subscript 2. The number of successes in the first sample is X subscript 1. The number of successes in the second sample is X subscript 2. The sample proportion 1, which is P hat 1, is X1 over N1. And the sample proportion 2, which is P hat 2, is X2 over N2. And then Q hat 1 is the complement of P hat 1, which is 1 minus P hat 1. And the complement of P hat 2 is Q hat 2, which is 1 minus P hat 2. Next, we have the pooled sample proportion, which is denoted by P with a line over it, and it combines the 2 sample proportions into 1 proportion, as shown here to the right. So the pooled sample proportion is equal to X1 plus X2 divided by N1 plus N2. And the complement of Q with the line over it is Q, which is equal to 1 minus P. So we would say that the pooled sample proportion and the complement of the pooled sample proportion is Q equals 1 minus the pooled sample proportion. Requirements. Number 1, the sample proportions are from 2 simple random samples. Number 2, the 2 samples are independent. Samples are independent if the sample values selected from one population are not related to or somehow naturally paired or matched with the sample values from the other population. Number 3, for each of the 2 samples, there are at least 5 successes and at least 5 failures. That is, N times the point estimate is greater than or equal to 5, and N times the complement of the point estimate, Q hat, is greater than or equal to 5 for each of the 2 samples. In step 1, you're going to state the claim and the opposite of the claim. In step 2, you're going to identify the null and the alternative hypotheses. The null hypothesis is the statement is assumed true until evidence indicates otherwise. The alternative hypothesis is the claim to be tested. There are 3 ways to structure a hypothesis test for 2 population proportions. Okay, so for the null hypothesis for the two-tailed, left-tailed, and right-tailed, it's going to be population 1, or P subscript 1, is equal to population 2, which is P subscript 2. And then the alternative for the two-tailed is P subscript 1, or population 1, is not equal to population 2. For the left-tailed alternative hypothesis, population 1 is less than population 2. And the right-tailed alternative hypothesis is that population 1 is greater than population 2. Now, the alternative hypothesis is the one not containing equality. So the alternative uses the symbols less than, greater than, or not equal to. And the null hypothesis is a symbolic expression that the parameter equals the fixed value being considered. Number 3, we're going to use the alternative hypothesis to determine whether it is left, right, or two-tailed distribution. And then number 4, we're going to select the significance level. So based on the seriousness of a type 1 error, you make alpha small if the consequences of rejecting a true null are severe. The values of 0.05 and 0.01 are very common. Number 5, the test statistic for two proportions with the null where P1 is equal to P2. So here we have the following. Z is going to equal parentheses P hat 1, or the point estimate of 1, population 1, minus the point estimate of population 2, minus the quantity of population 1 minus population 2, divided by the square root of the pooled sample times the complement of the pooled sample, divided by n subscript 1, which is the size of the sample for population 1, plus the pooled sample times the complement of the pooled sample divided by the sample size of population 2. Now I do want to point out here that if we focus on this part right here, okay, over here in the null hypothesis, you're going to see that P1 is going to equal P2. Now, if we wanted to get everything on one side of the equal sign, we would have to subtract P2 to the left side. So that means P1 minus P2 is going to equal 0. So that means that this, what's in parentheses, is always going to equal 0 in the formula, because when we subtract P2 to both sides, it's always going to equal 0. And you'll see that when we get to our future examples. Okay, so here you have it, where P1 minus P2 is equal to 0, and that is assumed in the null hypothesis. And then the pooled sample is x1 plus x2 divided by n1 plus n2, which is the pooled sample proportion, and Q here is the complement of the pooled sample proportion. And then part 6, find the corresponding p-value or critical value. So you want to draw your curve and label. When you're finding the p-value or the p-value method, p-values are provided by technology or using the standard normal distribution. And the reason why it's a standard normal distribution because our test statistic is in the form of z. And the critical value method, critical values are provided by technology or using the standard normal distribution or table A2. And then you're going to make a decision. For the p-value method, you reject the null if the p-value is less than or equal to alpha, and you fail to reject the null if the p-value is greater than the significance level. When using the critical value method, you reject the null hypothesis if the test statistic is in the critical region, and you fail to reject the null hypothesis if the test statistic is not in the critical region. Then number 8, you're going to state the conclusion. If the original claim does not include equality and you reject the null, you would state that there is sufficient evidence to support the claim that, followed by the original claim. If the original claim does not include equality and you fail to reject the null hypothesis, then there is not sufficient evidence to support the claim that, followed by the original claim. If the original claim includes equality and you reject the null hypothesis, you would then state that there is sufficient evidence to warrant rejection the claim that, followed by the original claim. And if the original claim includes equality and you fail to reject the null hypothesis, then you would state that there is not sufficient evidence to warrant rejection the claim that, followed by the original claim. Okay, then we have the confidence interval estimate of P1 minus P2 equals 0. The confidence interval estimate of the difference of P1 minus P2 is, well, we have the point estimate 1, the quantity point estimate 1 minus point estimate 2, minus the margin of error. That represents the lower limit. And over on the right, we have the point estimate 1 minus point estimate 2 plus the margin of error. And therefore, what's in the middle is what we want our confidence interval estimate to be. Now, the margin of error, E, is given by the following. E is going to equal the critical z-value times the square root of point estimate 1 times the complement of point estimate 1 divided by n1 plus point estimate 2 times the complement of point estimate 2 divided by n2. And then we round the confidence interval limits to 3 significant digits. Equivalent methods. When testing a claim about two population proportions, the p-value method and the critical value method are equivalent. The confidence interval method is not equivalent to the p-value method or the critical value method. Recommendation: if you want to test a claim about two population proportions, use the p-value method or the critical value method. If you want to estimate the difference between two population proportions, you use the confidence interval method. Hypothesis tests. For tests of hypotheses made about two population proportions, we consider only tests having a null hypothesis of P1 equals P2. So the null hypothesis is P1 equals P2. With the assumption that P1 is equal to P2, the estimates of point estimate 1 and point estimate 2 are combined to provide the best estimate of the common value of point estimate 1 and point estimate 2. And that combined value is the pooled sample proportion P given in the preceding slides.